Hello, Algebrainiacs. Welcome to the Johnson-Kendra video hour.
But it's not an hour.
All right.
This one could be. We'll
Yeah,
see.
yep. Here we go. So, section 5.5, root theorem of polynomial equations. All right, how do you find the roots when it's a cube function here? You can't factor, you can't do quadratic formula, and you can't break your pencil because you don't know what to do. So what we have is called the rational root theorem. Rational, the first 5 letters, remember, spell ratio. That means there are going to be some fractions involved. So what you do is you take a combination of the factors of the last coefficient, which is our 5, and the factors of the first coefficient. And then you do a combination. You make fractions out of all of those. So let's look at the problem above, shall we? 2x cubed minus x squared plus 2x plus 5. All right, so what are the factors of 5?
So we first want to look at what multiplies to get us 5, and I think we could do 1 times 5. But think if it's a positive, you could also have a negative 1 and a negative 5. So I think it's easier to just take that number, those factors, and just put like a plus or minus in front of them. So you're going to really have twice as many options.
All right.
How about the 2?
Plus or minus 1 and plus or minus 2 are the only choices.
Okay. All right, so what we have to do is come up with this list of possibilities, and this is what Kendra was talking about here. We take the factors of the last coefficient and divide it by the factors of the first coefficient. So I'm going to start with the 1. If we do 1 divided by 1, that gets us 1. But remember, it could be positive or negative, so that's where these are coming from. Okay, positive 1 and negative 1. We could take the 5 and divide it by the 1. That's how they get plus and minus 5. That's where these are coming from, etc. Then you got to go through all of them. So 1 over 2, 5 over 2, that's where all those things in the list come from. So how do we find out if they are a root? Okay, what we're going to do is we're going to test it in the polynomial. So if you think back to our equation here, you're going to take these numbers and you're going to substitute them. So we would do 2 times 1 cubed, etc. Plug it all in and then see what value we get. And to save some time, Mrs. Kendra worked them all out. What did we get when we plugged in a 1?
Plugged in a 1, you get an 8.
All right.
Negative 1 is 0.
Okay.
Then 240, negative 280, 6, 7 halves, 35, and negative 75 halves.
Okay, and this is one way to test if it's a root. We're going to show you another way in a second. But so anyway, here are our testing lists here.
You said RR.
RR. Our
There we go.
results. And I noticed that when we plug in a negative 1, we get a 0. And what that means is if we were to do synthetic division with that negative 1, we learned this when we learned synthetic division and remainder theorem, we would get a remainder of 0, and what that will do is create a leftover polynomial. So I'm going to set up synthetic division with the 1 that got us a 0. So 2, negative 1, 2, and 5. Remember, that's my coefficients I'm getting from the polynomial here. We're going to do synthetic division there.
Bring it on down.
Yep, drop the 2, multiply by negative 1, we get negative 2. Add them together, then we're going to multiply again, we get a positive 3. Add them together, we get a 5. Multiply by negative 1, we get a remainder of 0. And we actually already knew that we would get this because we got p of negative 1 equal to 0.
And if you don't get 0, you did something wrong.
Right.
So back it up.
Right, when you do your synthetic division. So this is a polynomial 2x squared minus 3x plus 5. I know that this polynomial is going to have 3 roots. This is one of them. And now I have this simplified down to a quadratic.
So now we could do factoring or quadratic formula. And you won't have to break your pencil because you know what you're doing.
Right. So I'm going to do quadratic formula.
All right.
All right. Negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. It's going to be a 9. Oh, let's see, negative 40. All divided by 4. This is the square root of negative 31.
31.
That is a negative, so when I simplify it, it's going to be I root 31. I think 31 is prime, so we're not going to be able to simplify this. How many solutions does this represent?
Dos.
There are 2 roots there, and the other root that we have is coming from the thing that
Okay, so now we want a little shortcut here. We want to still find all the combinations, and we're still going to have to try some to figure out one that ends with a 0.
All the possibilities.
But we're going to use synthetic division for this because it's faster and more fun. So, list combination. So we've got to have the 2 and the 15. So for the 2, I'm going to write down its factors. For the 15, it's either 1 and 15 or 3 and 5. Now let's talk about the whole numbers here. If I take this 1 over each one of these, I'll get 1, or I'm sorry, take it the other way around. Let's take just the whole numbers. We're going to, okay, let me back up a little bit. So we're going to take this 1 over this one and get 1, and remember the plus or minus. Then this 1 over all of these other 3, so plus or minus 1/3, plus or minus 1/5, plus or minus 1/15.
Holy cow!
Yeah, there's a lot. Now we're going to take the 2 and put it all over those. So 2 over 1 is just 2. Then 2/3, then 2/5, then 2/15. Wow. Okay. Now that's a lot of choices here. Fractions are a little tougher to do in synthetic, so we're going to start with the whole number. So I'm going to try 1 first. So I'm going to put 1 in the press box, and then I have my 4 coefficients. So 15, negative 32, 3, and 2. Bring down the 15, multiply, that's negative 17, multiply, that's negative 51, multiply, and negative 49
is not
a
0.
So that's not going to work. Let's try it with the 2. Press box. Thank you. Negative 32, 3 and 2. Bring down the 15. That's 30. Add, I get negative 2. So that's negative 4. Then I get negative 1. Multiply, I get negative 2. There's our 0. Happy day. So we know that 2 is a factor.
It's a root.
Okay? Or I'm sorry, a root, yes. So now this leaves us with 15x squared minus 2x minus 1. And we can factor that quadratic formula or factoring it normally, but I don't think it can factor normally. All right, so we're going to do negative b plus or minus b squared minus 4 times a times c all over 2 times a. All right, try that. 2 plus or minus. We got 4 minus 60, or plus 60. So that's nice. We got a 64.
Also,
a
could
30
be
on the bottom. Yep. So 2 plus or minus. Square root of 64 is 8. Now you have to do each of these. We're going to do 2 plus 8 is 10 over 30, which is 1/3. And then we have 2 minus 8, so that's negative 6 over 30. So it's negative 1/5. So those two are other ones. Now if you notice, to go back up here, those are in our choices. We have the 1/5 and a 1/3. Oops, a bit more. So there and there were the choices. And then the 2 is our other one.
Now, that just shows you sometimes all of your roots end up being rational numbers and listed in your possibilities. When we did our first example, when we got down to the solutions at the end, this obviously did not appear in our list of possibilities because that's an imaginary number.
That's why it's just possibilities, not the actual.
Right.
Yeah.
Okay, on to the next concept. So this is the conjugate root theorem, and it says that if a plus root b is a root, then also a minus b. So we've talked about conjugates previously, so it just automatically says that there is one of each sign, and it's that middle sign, remember, that is changing. It works for complex numbers, and it also works for these as well. So here they tell us that we have a quartic polynomial. What does that mean?
Quartic is 4.
Okay, now that's a little hint for you. That tells you that there should be 4 total roots in the end. They're telling us that we have one of them that is the square root of 2, and the other one is 1 plus I. It asks us to find the others. We know that since we already have 2 to start, there's going to be 2 others. You change the sign on whatever the radical has or whatever the imaginary number has. So since they gave me positive root 2, I know that negative root 2 is also a root. And they gave me 1 plus I, so we know that 1 minus I is a root. And that's all we're being asked.
Now that's easy.
Yeah.
Sounded more complicated, but it isn't.
Now what about this, when they ask us to find the polynomial? That means find out what the equation is.
Yeah, so what we have to do is set it up with the parentheses and then FOIL it out. So right here I have a complex number and I have to find the other root. Okay, here's a clue for you. What's the other root? Well, this one's positive, so we have a negative 2i.
Now wait a minute, how come you didn't do it for the negative 4?
Because it doesn't have a radical or an I with it. It's
Okay.
just a normal one.
And it says that it's a third degree polynomial, so that we know that we should have 3 total roots.
Right.
So,
All right, the next step is to set it up in its factored form. And remember, it's x minus whatever the number is. So if I have a negative here, it's going to be x minus negative 4, which would make it plus. And then we have x minus 2i and x minus a negative 2i, which would make it another plus.
now that's the polynomial in factored form, but we want to FOIL it all out, right?
Right, so I'm going to take these two first and FOIL them out, and then we'll take this one at the end and distribute with that. All right, so we'll start. X times x is x squared. Let's write this other part so I don't forget it. Sometimes I tend to do that. X times 2i is plus 2xi.
Whoa.
Then negative 2i times x is negative 2xi again. And then this negative 2 times this positive 2 is negative 4i squared.
We know I squared.
I squared is negative 1, so this isn't really negative 4i, it's positive 4, because negative 1 times negative 4 gives you positive 4. Okay, let's see what else we can do. Yep, we got these two. I have a plus and a minus, so those
Phew.
are going to go away.
I didn't know what to do with those anyway.
Yeah, and that's what's going to happen. The i's are going to disappear in this next round. So I have x plus 4, then all of this, I have x squared, then all I have left is this plus 4. So that makes it much simpler now to FOIL it out. So we can FOIL it again. So x times x cubed, or becomes x cubed, then we have 4x, then we have 4x squared, then we have positive 16. The only thing left to do is put it in standard form. So I have x cubed plus 4x squared plus 4x plus 16.
And at the end, we've got an x cubed. We were supposed to end up with a third degree. So, good way to check. All right, last one. I'm not sure we're going to get all the way through it, but we'll at least get you started here. This time, we're doing the same thing, writing the polynomial, but they give us some roots that are a little more complex. So I have 2 minus 3i, then I know automatically that 2 plus 3i is a root. These are just normal numbers, so I don't need to find their opposite. So I'm going to actually have 4 sets of parentheses. One of them is x minus 8, one of them is x minus 2, and then these get a little bit tricky. Here's what I suggest. You do x minus, and then within there, 2 minus 3i.
Oh, so brackets help to
Separate what we have, yeah. Okay. I'm pretty sure you guys could handle foiling this.
Yeah, I could probably do that too.
Okay, so I'm going to focus on these. So first thing we need to do is just distribute this negative to both. That is really important. You're not distributing the x. So this is going to change to minus 2 plus 3i. And this is going to change to x minus 2 minus 3i. So if you notice these parentheses, the only thing that is different is the sign on the 3i. Everything else should be the same. And then we need to multiply those together. So I'm going to do x times x. That's x squared. X times minus 2 is minus 2x. X times 3i is 3xi minus 2 now times the x, minus 2x. Minus 2 times minus 2 is plus 4. This will be a minus 6i. No, plus 6i. Thank you. Then we have to do plus 3i times x. That's going to be a positive 3xi. 3i times negative 2, that's going to be my negative 6i. Oh, am I to last times last finally?
Yeah.
Here to here, we've got minus 9, and it is I squared. Remember, I squared is negative 1, so that's going to change that to plus 9.
Woo!
That is crazy. But if you look, when we go to combine some like terms, I have this weird thing, 3xi. I should have an opposite of that, so those will cancel. Also, I have positive 6i and negative 6i, so those will cancel. And also remember your I squared canceled out as well. So now I have...
No more i's.
Right.
That should always happen in this round.
They must disappear. I have like terms here, minus 4x, and don't forget you can put these guys together as well. All right. We would need to continue. You should FOIL this together. That'll give you a trinomial here as well. And then you would have to multiply these together.
So 3 of those times 3 of those, you'll have 9 that you'll have to combine like terms again.
And you would get x to the 4th something.
Right.
All right.
Okay, we'll see you in class. Ta-ta for now.
Bye-bye.